Good morning, everyone. I'm Bryon Neitzel. I manage the High Performance Data Division for Intel. I think they put us up first to just kind of clarify any misunderstandings or calm any consternation about what's happening at Intel with Lustre. I'm going to briefly cover what's happening with our business model change, go through some of the work we're still doing and continue to do on Lustre, as well as some of the other IO stack projects that are underway. So the business model change that we just went through really affects how we deliver Lustre to the marketplace. It does not really affect the products themselves or how we create those products. The Intel contributions that we make now all go directly to open source. Everything that we do is freely available. There's no support license required. So there will no longer be an Intel branded release. In the Enterprise Edition that we previously made, we had Hadoop adapters, we had the Intel Manager for Lustre, what we call IML, some other components that were only accessible by getting a support contract. Those are now all available. They're either out on open source or will be shortly. Our sales team has been consolidated with other groups inside of Intel, so the HPDD team now focuses on their core competency, which is level 3 support, and we're relying more on our partners for the distribution and implementation of Lustre deployments. One notable effect of these changes is that we no longer have a Foundation Edition or an Enterprise Edition. And so the additional testing and stability that happened in those releases now is all focused on the community release. So I'm sure Peter's engineers are happy about this, but there's fewer releases for that team to manage and track and test and publish. And so all that work is now concentrated on community. So we think it's going to make the team much more efficient and put a better product out there right away that's available. So I think it's also significant to note what didn't change. So our delivery of feature releases, I'll have a roadmap in a minute. You'll be hearing more about the roadmap over the next few days. The support for existing and ongoing installations for both Intel branded releases and community releases is unchanged. Our development, test, release, support, R&D teams are unchanged. The massive pile of Intel hardware that they've given us to do our development and testing on is still there and growing. And our involvement in large-scale deployments for projects that Intel's leading, we are using Lustre well into the future for these deployments. And of course, we're here. We're still participating in all the community events, mailing lists, et cetera, like OpenSFS, COFS, LUG, LAD, et cetera. So a quick look at our roadmap. 2.9 is out. 2.10 is underway. We have engineers debugging and testing it as we speak. There's actually quite a significant list of features coming out in 2.10. I think Peter's going to be talking about that later this morning. The ZFS snapshots, multi-rail, dynamic striping, project quotas, all I think represent a substantial step forward in Lustre. And then looking forward, Andreas will be talking about 2.11 and 2.12 features with dynamic striping, some replication, et cetera. So we have quite a bit of work underway. Projects that aren't even on the roadmap are being worked on. So there's still quite a bit of activity moving Lustre forward. Performance is still a big focus of what we do. So today we have roughly 10K crates a second on a ZFS MDS, 5 to 8 gigabytes a second on an OSS, 8 gigabytes a second network performance. By the 2.12 time frame, we think that we'll be around 150 crates a second on an MDS, substantial small file performance improvements, 18 gigabytes a second per OSS, and 20 plus gigabytes a second network performance with the multi-rail features. So performance continues to be a top criteria for our Lustre releases. One interesting slide, this was presented at LAD last fall, so I apologize if some of you have seen it before. Shows a couple dimensions of performance that I think are interesting. With 2.9, I think we put in the final features for the distributed namespace feature. And so you can see our scaling on up to 8 MDTs is nearly linear. And the dark blue represents ZFS 6.5, and the light blue represents an earlier release of ZFS 7.0. We get nearly 3x the performance on creates with the later ZFS. Intel's been participating in a working group with some really talented ZFS engineers from Delphix and Livermore. And I think it started about a year ago. We came up with a pretty long list of improvements to be made in ZFS. And you're seeing the results of that now. I believe we're up to RC4 on ZFS. Brian Behlendorf just mentioned Livermore is running that in production, which has even more performance improvements in it. So tangible results of some of the work that we have been doing and continue to work on. Probably one of the most notable changes to our products would be around IML. IML used to be entirely proprietary, so it did require a support license to get access to it. It's our management and monitoring tool. We have a really talented team of engineers that continue to work on this and improve it. And it makes a Lustre much easier to manage and maintain. So this code is all moving to open source. And as of today, it's out on GitHub, and we are able to take contributions on the code base. So it's set up as a mono repo. And IML is today a somewhat monolithic piece of code. We're working on breaking that up so that you can take pieces of it, say a device scanning capability or a job stat monitoring, and eventually you'll be able to deploy those pieces separately. The CI mechanism is set up so you can check in changes and automatically test, unit test, feature test those changes. The one piece that's not quite ready is we're still moving our Jenkins server from inside the Intel firewall to outside, but you still can do a full end-to-end test from a check-in. We're working on the open source roadmap for this, but community input would be greatly appreciated. We do plan on having a 4.0 release coming out next quarter that will be based on the 2.10 long-term stable release. So that's the Lustre work. We still have another probably half of our organization working on other parts of an I/O stack. So if Lustre represents, code that would span from a compute node through an I/O node to a Lustre OSS, the project that was started with Coral and working on the Aurora machine covers everything from the application down to ZFS, writing to a disk. So with ZFS, there's a dedicated team working on some new features for parity clustering and distributed sparing. We have a complete I/O forwarding solution that could work with either a burst buffer or without one. There's a tool we call Copper, which manages node local storage, so you can, for file per process workloads, more easily manage that, ideally with NVRAM, with mover tools that can move that from the compute tier to the storage tier, and an I/O library tuning team that's working on tuning libraries like MPI-IO for more fine-grained performance optimizations in a stack like this. The ZFS work and IO library work are actually available today, either through the ZFS on Linux project or Intel's MPIO product. The copper and the IO forwarding are in development, but those will be finishing the first versions later this year or early next year. And we're targeting to put those products into the OpenHPC open software stack. So looking forward, we see Lustre as our long-term POSIX compatible parallel file system for the indefinite future. There's the semantic compatibility is very hard to recreate, but there are new workloads, there's new APIs that we want to support, and as a result, we've been working on a product that you've probably heard of called DAOS, which has a completely new storage paradigm. We're completing this project through a program called ESSAO that we're doing with the Department of Energy. That's rendering the DAOS in pre-production quality code, and by that I mean it's code that doesn't need to be rewritten to productize it. So there'll be a longer-term stabilization and hardening effort for this. But today, some of the features that are available, it renders the data model and the key value interface. It does data replication, online rebuild, metadata replication, snapshots, etc. That code is all Apache licensed, and it's out and available for contributions. And we have several projects underway already with customers that are porting their middleware to DAOS so they can run their applications on top of it. So in summary, we still see Lustre as the future of scalable POSIX storage. It's not going anywhere. We think it's going to be around for a long time, and it is a key piece in our complete IO stack solution. So all the other components that we're working on that I mentioned for the Coral project rely on that parallel file system being there. DAOS is a longer-term vision for new workloads, for analytics, for machine learning, with a different interface that would take advantage of NVRAM and byte granular storage. So I hope I've convinced you that the work is still underway at Intel, Lustre's not going anywhere, and we think it's got a long future. If you have any specific questions, I'll take one now, but Peter and Micah, if Micah's here. Micah, are you here? In the back of the room. And I are happy to answer any questions about specific, customer deployments or issues or what have you, on a break or offline or at lunch or what have you. So I'll take one question.
Hello. So Bryon, this is for you and also for Peter. So you didn't mention about Lustre for cloud. Anything progressing there?
I'm sorry. Can you say it again?
There's a cloud edition for Lustre. Which Intel was working on. You didn't mention about that. So
the cloud edition is still there. We're deciding how to wrap that into a bigger cloud effort, a strategic effort that's underway right now for the technical computing part of Lustre. But you can go to Amazon today and subscribe and use the cloud edition for Lustre.
Okay, I see. Okay. Thank you.
Sure. All right.
Thank you, Bryon.
Thank you very much.